This Delta Math topic is over prediction from a line of best fit, which is basically saying we've got a scatter plot because in the real world, data is kind of all over the place, but we see trends, right? So that's a scatter plot. Scatter data, scatter all over the place. And we want to see, well, let's take that information and kind of make a straight line cutting through. So here's an example of that. We've got all this yellow data on here, and we want to draw approximately a trend line. That's what that is, okay? And you are approximating, it's not perfect. There's going to be different data that doesn't fall in that line, but that's going to help us make decisions with the numbers that we've got available to us. So the question says this: a researcher studied the relationship between the number of times a certain species of cricket will chirp in 1 minute and the temperature outside, because they are related, right? And that's what any of these graphs is. We have one set of data and we're comparing it to another set of data. And the best way to do that is to have two number lines. So we compare those two pieces of information and we get a relationship, okay? So we express our information on the data plot. Always make sure you understand what's happening on your graph, right? Understand what the numbers are talking about. Chirps per minute, okay? And it's not 1, 2, 3, 4, 5, right? Your scale is going by threes, okay? So we're not just counting lines. Your scale goes by threes and it starts at 60 because they don't want to draw all those numbers. Like they don't want to write out 3, 6, 9, 12, and so on, right? So we start out, we have this little jagged part of the line, which indicates that there's like a jump here, and then they get going with that data. And we also have a jump here, and then they get started with that data. So this is the temperature. These are the chirps per minute. So based on the line of best fit, which is a linear equation or linear line, it's a straight line, predictable, nice boring slope. How many times would the cricket most likely chirp per minute if the temperature outside were 65 degrees? So you'd be like, oh, okay, I'm just going to look at my graph. But look at that. It only goes to 63. So if they're basically saying make a prediction based off of the data that we have, we only have information up to 63 degrees. So 65 degrees would be about up here, right? So my line, if I drew it well, is going to come down and meet me right here. Probably like, I'm going to say like 96-ish or something like that if I do a quick assessment. Now they're going to break it down a little bit more specifically for you to say, okay, take your time. What's the slope? Apply the slope. And the slope is, remember, the slope is just how we connect our points, how we connect our dots. And so if there's like a relationship of when things per minute aren't happening very quickly, it's going to be changing like less. It's going to be like a flatter line. When things change quickly, we bump that up because time's going to go by and big changes are happening. So you're going to get steeper lines when things change quickly. So when we look at a problem like this, they kind of hone in on up here in this area. They look at these 2 points and they find what's the change. The slope is always the change up and down over the change left and right. So it's the elevator run, elevator run, elevator run, and it connects our points that way. So the change between these two numbers, if you can't see, it says 93.63 is 1 point and 90.62 is the other. So if we zoom in a little bit more here, well, we went up and over on each point, even more zooming in, we went up 1 degree over 3 chirps per minute. Up 1 degree, 3 chirps. Up 1, 3. So that's a slope of 1/3, 1/3, 1/3, 1/3. Elevator 1, run 3. Okay, that's just the relationship between chirps and temperature. So, so if you follow that, if you go up another degree from 63 to 64, which wasn't on our original graph, and then another degree, we went up once and went over 3, up once, over another 3. We went over 3 twice. So we have to add 6 to our to the end of our number. We were at 93 before, 93 chirps, and 93 chirps. So we went over 6 more chirps if we went 2 more degrees up. Okay, and that gives us an answer of 99 chirps per minute. Okay, all right, that one was a little bit funky. Okay, a little bit weird. For all sorts of weird story problems at you. So the next one says a line of best fit was drawn to the plotted points in the data set below based on the line of best fit. For what y value does x equal 14? So they don't even tell us what's happening in this problem. They're just saying, hey, look, if x is 14, here's that set of data. We only go up to 12. So 14 is going to be two lines over, right? So if I follow that up, where do I predict it's going to hit me on this line? Okay, maybe like 12-ish at a quick glance. Okay, but if you're not sure, follow the pattern. We go from 10 to 12, so we went up, up actually 10 to 12 is this way. Sorry, our x's are the left right movement. So we went over 2 and up 1, or up 1 over 2. Both ways count. But we like to do elevator then run. So up 1 over 2, up 1 over 2, up 1 over 2. And we keep following that pattern. And so if we made it a little bit bigger, easier to see, okay, up 1 over 2, up 1 over 2, we would, when x is 14, we went over 10, 11, 12, 13, 14. It took us all the way up to 12. So my prediction was right. This is number 12. So where those two pieces of information meet, that point is representing that situation. So when x is 14, y is 12.